1. All right. We didn't, and I understand if you had a question about this, because the ones we did in class, they all went off forever in one direction, and this one really didn't. Oh, she said y'all could come, the 3 y'all could come. So let's talk about what we did here. Remember, all these are lines that we are cutting off, okay? So this is a line that we are cutting off between -6 and 3. So what I can do is, in this case, I can plug both of these in for x and find the 2 endpoints, essentially, and then just connect them. So if you plug -6 in for this one, I get 3 times -6 minus 4. -18 minus 4, which is what? Y'all can do that much math. -22. So this point would be -6, -22. Does that make sense? Yes, that makes perfect sense. Okay, so that's one endpoint, right? So 1, 2, 3, 4, 5, 6, and then all the way down. It's going to be closed because, and I'm just going to pretend like I went down to 22. Yes, that's fine. And now I'm going to do the other endpoint, which means I'm going to plug in the 3. So 3 times 3 minus 4, which is 9 minus, why did I put, my brain got ahead of my, so 9 minus 4, which is 5. So this other point on the other end is 3, 5. Right? 3, 5. These are just going to, oh, I did that wrong. What did I do wrong? It's supposed to be open. Why is it supposed to be open? There's no line underneath it. That's exactly right. Connect them. That's the first one. Okay. That is the line 3x minus 4. It's got a slope of 3. Oh no, that's not right. Oh, because I didn't go down far enough. That's the only reason why. Yours should be crossing the y-axis close to -4. And then if I do the other line, I'm going to plug in 3, and then I'm going to plug in 6. So if I plug in 3, I get 10 minus 3, which is 7, right? So this point is 3, 7. So right above, is it opened or closed? Closed, because there's a line under it. And then I plug in 6, and I get 10 minus 6, which is 4. So 6, 4. Open or closed? Thank y'all. No. Here. Okay, so this is where, think about on Desmos yesterday, right, where we were shading. So this would be solid, so you're right, bracket negative, what'd you say, 6? And then it keeps going, it keeps going. What happens here? Well, one's open and one's closed, so it's still included. And then it keeps going until I get to this point. What is that point? It should be 6. Right? Did I do this one wrong? It should be -6, but this endpoint right here should be 6, 4, right? So it goes over to 6. Okay, key's wrong. I'm sorry. Thank you. Thank you, Logan. Wouldn't have been able to sleep tonight had you not forgiven me for doing that problem wrong. Yes. Yeah, I've been doing this way too long to pull them in from somewhere. Why? We did switch up curriculum not too long ago. The standards changed.
Wait, so this is solid line, like close is the bracket.
Yes.
Now we got the
So left to right. So this is the furthest left it goes, and it's a closed dot, so that's why it's -6, and that's why it's a bracket. And then as I move across, this is not breaking up my graph up and down because this point's included here. But this point is open, and I take the x value there, which is 6. And then range, which is bottoms up. What's the lowest the graph ever goes? -22. Is that included or excluded? Solid dot, open dot. Closed dot, which means bracket. That's exactly right. And then as I make my way up, what's the highest it goes? It stops here, but there's more graph here, so I include it. But what's the highest it ever goes? 7. Bracket or parentheses? Y'all let me label that point wrong and everything. Yeah, 3-7. It's just a day for me to mess up today, apparently. Thank you. If I what? What else on your homework did you struggle with?
No, I got you.
Yes, I'll be happy to. I was going to say, today we're going to do greatest integer. Technically, this unit is set up for piecewise and greatest integer to be taught together. But I've always found students struggle with this. So we split it into not just 2 days, but 3 days with the piecewise and everything. So you'll have, what I'm getting to is you'll have some more piecewise practice tonight. It'll be very, very soon.
Tomorrow.
Very soon.
It's been a day, I'm small now. Which one is this?
Okay, so these are all horizontal lines, right? Because y equals 2, y equals -1, and y equals 3. Those lines all look horizontal, right? All right. Well, if I asked you to graph y equals 2, that just means you go to 2 and you do that, right? There's no x or anything in it, right? So that's what I'm doing, but the difference is I'm only doing it when x is smaller than -3. Okay, so 1, 2, 3. Would it be opened or closed? Closed. So if I plug in -3, what do I get out? There's no x there, so you always get what? 2. So -3, 2, you said it's closed. Then pick an x that's smaller than -3. What's smaller than -3? -4. What do you get out? What's the equation? You're right. It's 2. It spits out 2 it doesn't matter what you plug in for x. It's spitting out 2 every single time. It's saying y is always 2 no matter what x is. So now I go -4, 2, and I connect this way. It's a piece of a horizontal line. That's all it is. You could have just drawn the horizontal line if you understood. I was just showing you because that's the process I used yesterday to show you how to graph them. Next piece of line is -1, but it says in between -3 and 3, right? So when it's -3, what is y? -1. And when x is 3, what is y? -1. It's always -1. Okay, so this equation says y equals -1 no matter what value x is. So if I let x be -3, y is -1. If I let x be 3, y is -1. No matter what I let x be, y is going to be -1. So -3, -1, and 1, 2, 3, -1. It's just that piece of a horizontal line, but it's cut off so that it's only between -3 and 3. Does that make sense? Okay. The last one then, when x is greater than or equal to 3, I'm the horizontal line at 3. So if I plug in 3, I get 3. If I plug in something bigger than 3, maybe 4, again, I still get 3 because it's at the line 3 here. So 3, 3, close dot because of the line under. So there's what that graph looks like. Does that make sense? Does it make dollars? It makes change. How about domain here? Left to right.
Yeah.
Range is a little bit harder because the range is just 3 numbers and just 3 numbers only. So if I want to think about interval notation, y can only be one of 3 things. Y can be -1, it can be 2, or it can be 3. That's it. There are no other values y can be. So what I would do is I would say I'd start with the smallest, -1, 2, or 3. The range just has 3 values in it, and that's it. Depends on how the domain is restricted. Like if this line had not been here and it was only these 2, then my domain would be -infinity to 3. See what I'm saying? Because it stops here, and if it doesn't have this, there's no more graph past 3. So it just depends. Yeah. Yes. It's probably wrong on mine if y'all are in question. Let's see. Let me just run through graphing it real quick, even though you just wanted the domain and range. Less than 3. So both of these, the first thing I noticed that's different about this one is both of them are exclusive, which means they don't include that 3. There's no line under there. So I'm going to plug in my starting point. When you plug in 3, first you get 4. And then I need one smaller than 3, so maybe I pick 2. If you plug 2 in here, 2 plus 1 is, of course, 3. So that piece of the graph, 1, 2, 3, 1, 2, 3, 4. This is open, and then I've got, oh, why did I do negative? And then 2, 3. And then the second piece, if I plug in 3, 2 times 3 is 6, and 6 minus 4 is 2. Then I need a number bigger than 3, so I'll choose 4. 4 times 2 is 8, and 8 minus 4 is 4. Y'all hear that? Where's that coming from? That's not coming below us? No. See, 3, 2, open dot, 4, 4. So domain, yes, I'm assuming that I didn't leave anything out of the domain like I should have. I've got to leave out this 3 here because both of them are open. So there's your domain. If one of them were closed, if this looked like this, then it would just be -infinity to infinity. But because at this point 3, they're both open, then there's no graph right there. That's one place where there's no graph at all. And so that's why I have to leave that 3 out. Now, as I look at range from the bottom up, I am negative infinity to infinity there. These are tough. We'll practice with these some more today, too. I know you're so excited. 20. It never goes away. We were talking about that yesterday in pre-cal. I was like, y'all remember how you struggled with some of this stuff and now you just do it like that? It's really, we'll do it so much you'll. $25. So we're going to look at things a lot more like this today, too, that have 3 parts to them. Some of those parts may even be a quadratic instead of linear. It could be wrong. All right, so I'm going to start by finding my points. That's always the way I go about these and attack them, especially if they're linear this way. So if I plug in 1, what do you get? 2. Thank you, Abby. Then if I plug in one that's smaller than 1, maybe 0, what do you get? 1. Open dot on the starting point. So 1, 2, open dot, and then 0, 1, close dot. There's the first graph. Second graph goes in between 2 values. If I plug in 1, what do you get? 0. Then if I plug in 3, what do you get? Negative 2. 1, 0, which would be closed, and then 1, 2, 3, negative. Open. And then for the last one, if I do 3, I get 2. And then if I do one bigger, so 4, I get 3. So 3, 2, closed. 4, 3. Domain here. That's right. Every place there's a break, there's a point that's included there. How about the range? Same thing. Function. This is a piecewise function, but it's going to be a little bit hairy. It's not really hard. I think that piecewise you've been doing is harder than greatest integer, but let me explain what it does. It looks a little funky. It looks like these weird brackets this way. Now, tell me what an integer is. What's it mean to be an integer? That's not absolute value, no. Greatest integer function. What is an integer?
A real number. Yeah, but it's a number, I know that.
It is a number. What kind of number?
A real number.
It is a type of real number.
A positive number. No. A whole number.
It's like it's just like fancy brackets. They have an extra line in them. What kind of number? Besides real number.
Whole number.
Whole number. It's a whole number that can be positive or negative. That's what I'm like. If I say integer, that means there's no decimal there, right? Are y'all with me? Did y'all what? Nobody ever taught y'all whole numbers, integers, fractions, decimals, types of numbers? Okay. Okay, integers are just, okay, whole numbers technically don't include negative numbers, but it's numbers with, it's whole numbers that are also negative. Okay? Integers can be positive or negative, no decimal. Just nice, even whole numbers, okay? That's an integer. But I can plug anything I want to in here. But what happens, what are you doing?
I was going in my seat, but I wasn't stepping on the track. You need to be more than a special class. You need to be a brand.
Okay. Here's what greatest integer function does. It rounds anything you put in down to the nearest whole number. Okay? Even though it says greatest integer, good morning, it actually rounds it down. So, if I said, what is the greatest integer? Let's say I put 1.2 in here. What would that be? What's the close? 1. It would be 1. Okay. So if I told you that f of x was the greatest integer, then what do you think f of negative 4.8 would be? Negative 5. Think about a number line, right? If this is negative 4 and this is negative 5 and I'm at 4.8, what's the closest whole number below it? It jumps down to that negative 5, right? How about f of 7? Just 7. Just 7. It's already a whole number. Huh? Well, I'm already defined it. I said f of x is those cool little brackets. So what is f of 7? 7, right? We're going to talk about what this looks like graphed, but give me just a minute. Never. Right now. It most definitely will. It teaches you to be a problem solver, to think analytically. Well, unfortunately, life is full of problems. Okay, now, here's what's going to happen. It's not going to be as easy as this because we're going to do things with this greatest integer function. Let's say I defined f of x to be the greatest integer of x minus 5. This is probably, I'm going to go out on a limb and say, brand spanking new to you. You've never seen greatest integer function. Am I right? Okay. Today. Okay. What would f of 9 be if f of x is... Okay. I'm just going to plug in so that you see. So I'm looking for the greatest integer of 4. So it's, of course, 4. Right? That might have been easy. How about f of 1/2? Think about them like parentheses. You do inside the parentheses first, and then you do the operation. Same problem. Okay, well, let's look. Let's plug it in. 1/2 minus 5. What's a half minus 5? So negative 4.5. Y'all keep leaving the negative off when you say it. Now, what's the integer closest to it but below? Negative 5. All right, don't blurt this one out. Blurter of answers back there. Find f of negative 8.1. You're not a blurter of answers.
So we always round.
Always round down. Okay, Mr. Blurter. You can tell me what you got. Ooh, are you sure? I disagree. I say this is negative 13.1. So if it rounds down,
But it's not greater than 5. It's not 5 or greater.
it's not rounding that way. It doesn't matter how far past it. Here's negative 13. Here's negative 14. Anything past it goes down to the next number. Yep. Yep.
That's not.
Why couldn't they have just made it normal? Because why do we have to learn the normal words? Hey, if you were to become a mathematician, could you go and change that rule?
I am a mathematician.
I know. Could you change that rule?
You can't just change a rule because math is what I mean. That's like saying, could you change the color of the sky?
Who thought of this? Yo, Mr. G, I got a hot take actually. Say if somebody learned their color different from we did, so the sky's like.
I know. I've had this conversation before. We have no way of knowing what anyone else is seeing. Your blue might be my green, but I learned to call it purple, so it's purple to me. Right. Who knows what everybody else is seeing? Right. Okay.
Would you like to work with me on a project?
No. Let's graph it. And this is one point where I think when you see the graph of it, it helps you really understand where these values are coming from. So it really brings everything together. So let's just start with the parent. Let's start by graphing the greatest integer of x. So let's start with the t-chart. And let's look at some values and let's see what happens and what we think is happening. Now, one thing that we know is that every integer, if you plug an integer in, if I plug in 2, it spits back out what? You can say it, you're right. 2, right? If I plug in -1, it spits back out -1. So there's actually a point at every integer, right? 2, 2, -1, 1. And in fact, all of these, and I'm just going to go 2 to 2. Here so you can see what's happening. 0, 0, 1, 1, 2, 2. All of these are actually points, right? I'm just randomly thinking of numbers. The thing is, if I plug in an integer, I get an integer back out, and I get that same integer back out. The only time things start getting a little is when I plug in decimals, right? So let's plug in a couple and see what happens. Let's just say decimals are fractions. Let's say I plug in a half. If I plug in 1/2, what do I get back out? 0, because it goes down, right? So I get 0. Well, 1/2 0 happens right here. What if I plug in 3/4? It's still 0, right? I'm making a point here with this. What if I plug in 9/10? And in fact, would you agree that if I plugged in 0.99999999999, I'd still get 0? So in fact, all the way until I get right up to this point, it's always 0. But here, I'm going to put an open dot because when it hits 1, it jumps up to 1 and it becomes 1, right? And now I'm back on the same process. So what about past 1? What about at 1.1? 1, right? How about 1.5? 1, right? And in fact, all the way up until I get to the next one, it's 1. This is the point where it jumps up here, and now it becomes 2 whenever I plug into it. Yes. So I'm just going to fill in some more of this. Okay, so let me show you the different lines. Okay, so look at the graph. Look at the pink lines on here right now, right?
I need to show it.
It's out.
Oh my God. Yeah.
Sleeping in that.
Maybe it's to bed.
Yeah.
Charlie. I like your shirt.
Go share it with Mallory.
Okay. It matches our.
Look. Let's say, remember, all the graph does is spit out solutions to an equation for you, right? So,
I'll get it. Don't worry about it.
let's say I want to know what the greatest integer of 2.5 is. If I go over to 2.5, what is the y value that goes with it? 2. So the greatest integer of 2.5 is 2. And this continues in both directions forever and ever. All right, give me any number decimal, well, between -2 and 2, but a decimal. 2.7. 1, 2.7 will be about right here, right? Where's the graph for that? Right here. That's at 2. So the greatest integer of 2.7 is 2.
Oh, that makes sense now.
Give me another one. Give me a negative one.
Negative 2, 3. Negative 2.
Give me a decimal between -2 and 2.
Negative 2.3.
Okay, well, how about negative 1.3? Okay, negative 1.3, about right here, right? What graph goes with that? This piece.
That's hard right there.
So it's
That's 2.
Come on, Chad.
But it's not 2 though. Those ones go with 1. Why don't you go with -1?
Go. You're down to take one.
You see how 1.5, when it's positive, there's a positive 1? What if it's negative, does it go with -1?
if it's negative, it still goes to the one right below it. So if it's negative 1.3, then that would be -2. Negative 2 is smaller than -1. So it always goes backwards, essentially, is what it's doing.
I'm happy to say
It makes sense.
like getting stuff out.
It makes sense. So when
Okay.
when you go negative, just go reverse. Like
Yes,
positive.
yes. Because once I get to this point right here, if I plug -1 in, I have to make sure I get -1 out, not -2. It doesn't jump until I get past that, so it's an open. And I could keep going with this. This keeps going forever and ever. Sometimes people call this, get ready for it, a step function. Do you see why they might call it a step function?
Because it looks like stairs.
It looks like steps, right? Okay. What is the domain on this function?
Negative 2.
Absolutely. Negative infinity to infinity. I can plug anything in that I want to for x. I can plug any decimal, any fraction, any of that in for x. It's the y that's restricted. How is y restricted? Right. And so for this one, I'm okay with you writing it as like a sequence of numbers, ... -2, -1, 0, 1, 2, ... If you want to do it like that, if you want to say y, and I'm going to teach you something fancy here. This means is a member of set of integers. That's a weird looking Z. It's a double line Z. It's the way, yeah, it has to be weird looking like that. Either way you want to do it is fine. It's hard to do this in interval notation, so we'll skip over that for now. And we'll just stick with this for step functions. These are the only functions I'll let you do it this way in. But yes, y has to be an integer here. Y is a member of, and then it's a Z with an extra line on it. The set of integers. Now this is something that's made up that could be whatever somebody one day just decided. I will let this fancy Z represent integers. All right, let's do one more example, but let's make it a little bit harder. This is just the parent function, and then I'll set you loose.
Oh, that's hard right there.
What? Here's what I would do. As you start these, I would plug in my integers first and see what's going to happen as I hit these integers. So at least -1, 0, and 1 and see what's happening. Then we'll start working in between those values. And maybe even, let's go -2. Let's go -2, -1, 0, 1, and 2. And let's see what happens at those points. And then we'll work in some, because you just have to get enough to pick up the pattern. These are all going to be staircases like that, step functions. I just got to figure out where I'm jumping from one to the next, right? And how far that spans. Okay, so first thing, let's plug in -2. If you plug in -2, what do you get? -6, right? I'm plugging in here. -2 minus 1 is -3, and -3, the greatest integer of -3 is, of course, -3, and then -3 times 2 is -6. What? What do you get when you plug -1 in? Yes. I'm plugging in this equation right up here. So 2 times -2 minus 1. Okay. Do the same with -1 and tell me what you get. Hank, what'd you get when you plugged in -1? How about 0? -2. It is a pattern. They all have a pattern. You got to figure out the pattern. All right, so let's plot these points. Remember, these are just points. I don't know what's happening in between. Sometimes they'll jump. You'll only make it halfway through and then they'll jump. Sometimes you'll make it a span of more numbers and then you'll jump. Let's see what's happening though. All right, -2, 1, 2, 3, 4, 5, 6. -1, 1, 2, 3. Well, I would at least start with this set of integers. No. Here's what I would do. I would pick one in between and I would see what happens. In between what? Well, let's just go in between 2 points and let's see. Am I connecting this way or am I connecting this way? What's happening? Let's try Let's try a half and see what we get. Put a half in there and see what you get. I got to figure out what's going on in between these points. Well, I do a half minus 1, right? Which is negative 1/2. What's the greatest integer of negative 1/2? 0. So I got 2 times 0, which is so at 1/2 is 0, right? But I'm not timesing it by negative 1/2. They're in these special brackets. I do. So I only round what's in those special brackets. So what is the greatest integer of negative 1/2? What's the closest whole number below it? Oh, wait. It is negative 1. I'm sorry. Dang it, Stacy. You're doing it all day long. I'm sorry, y'all. Not trying to confuse anybody, but doing it anyway. 1/2 goes down to negative 2. It doesn't look like a pattern. Okay, well, let's get a little bit closer. What happens if you picked, say, 3/4 or 0.9? Try 0.9 because that's getting really close to the 1 here. Try maybe 0.9. I can't believe I just did that. God, jeez. Yeah. Well, you can, but sometimes they might jump maybe halfway in between. So what if it did this and you had another here?
Is there a way to know?
Taking some points and looking. We're gonna learn transformation soon and you'll see why it's like this, but as of right now, no.
So we gotta find a point next to each one of these dots.
Well, no, because once you find the pattern, if you plug in 0.9, you should still get negative 2. So in fact, what's happening is until I get here, this is where it's making the jump. And then from each integer on, this is where it's making the jump. Once you have the pattern, plug in points. It does. You only have like 2 or 3. If I put 0.9 in, right? F of 0.9. 2 times 0.9 minus 1. What's 0.9 minus 1? Negative 0.1. If I round that down to the closest integer, negative 1, so it would give me negative 2. Yep. Well, if you see that already, yes. If I was doing this, I could have told without having to do that last one. I'd have been able to tell. But if you need it, do it. Yeah. Well, because if this point, I had all these solid points already on here. And then I said, well, I know that at 1/2 it's negative 2. Here's 1/2, here's negative 2. So that tells me this is going in this direction, and this is the point that it jumps up because I already had that point there. It's a function, so it can't have the same, so it's going to be open at the end there, and then jump up to the next. This point is 1/2 negative 2, right here. You could have, that's what I said, you could have put in 0.9 just to double check and make sure that it goes all the way through. The greatest integer of 0.1 is 0. They all round down. Did you have a question? Yes. 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 Not to the, yes, to the left. It was, but y'all didn't quite get it. So let me show you. Well, the example looks just like the homework. Maybe. Yes, they got to be stapled. The printer, I messed up. It didn't do front and back. I'm sorry. So staple it and give. No, you don't need the chair to do that. All right, see if you can figure out the pattern here. Take just a second and look at it. Start with your integers and see what happens, and then move into some numbers in between. This is a tough one. This is as hard as this will get right now. Staple to the right.
I don't need the staple on that, do I?
Yes, that's what I would do.
I'll just pass the staple.
Yeah, do that. I put a, there, it's going to need staples in a minute, but nope, 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 nope.
Here, but so you can start on your homework first. Now you would be proud. I know the answer, Mr. Garrison. Is it not right?
Clearly not.
Such an L. Can I try?
No.
Wait.
Hand the homework out.
I get distracted. I have 8 $11. Left day, okay? Okay. 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 Wait up, Charlie. Okay.
Shh. Yeah, Charlie.
That's on you. It's on no one else, but it is on you. I apologize. Young boy.
We'll see how I've already picked the pattern up. But no, well, I'm showing work, so that I'm showing all of this one. No, if you can do it, that's fine.
And the pattern that there is like repeating twice.
I hope if you did your T-chart that you at least found this much out. You have to find the pattern. That's exactly right. Now, instead of moving every one number, it looks like it's moving every two. So it looks like, so now I wonder, because here's what I got to do. I got to figure out, and this one's a little bit easier to see, I think. Yeah, it was supposed to be front and back, but it didn't run. Logan was supposed to be passing the stapler around. Okay.
Hot dog, diggity dog.
How do you find the open circle point? Okay, we got to find the direction that this moves, right? And we got to find the point where it quits being, what is this? 1, 2, 3, 4, and it jumps up to 5. When does that happen? Well, I know all the way here, in between these two, it's going to keep being 4, right? But the question is, once I move past 1, is it still 4? Like, what about 1.5? Well, I don't know, plug it in. If I go 1.5, because this is the process I'm going to have to use to see at what point, because I don't know where that open circle point is. Right? So now I need to know, okay, so 1.5, if I do 1/2, and here's where you're going to use your calculator, times 1.5 plus 4. 4.75. So it's still 4. What? So once you get, I always start with the integers first, because you know if you put in an integer, you're going to get out an integer, right? So I start with the integers, and then I start looking to see when is it making its jump. So like we just put in 1.5, here's 1.5 right here, and it's still going up to 4. So I'm thinking this, see where this positive point is? This is where it's making its jump right here, because it goes all the way across. So in fact, what's happening is it's spanning 2 numbers instead of just 1. Because what happens when you plug in 2? You don't get 4, you get 5. It's jumped up. So you just have to figure out how far it goes before it jumps. That's what you got to figure out. How far this step goes before it jumps up to the next. Okay. Before it jumps up